All right, so get this. We're diving deep into a world where AI is going head-to-head with the best in competitive programming.
Yeah, no kidding.
We're ready to unpack some seriously cutting-edge AI research.
Let's do it. We're looking at competitive programming with large reasoning models, the latest from OpenAI. It's not just about generating code. It's AI that strategizes, adapts, and could even outsmart humans on some seriously tough problems.
Okay, so before we get too far into the matrix here, let's back up. Competitive programming, what's the deal? Why is this considered like the ultimate challenge for AI and even humans?
Imagine like coding on a deadline. You got algorithmic puzzles, a clock ticking, and a global leaderboard right there in your face. It's not just about writing code that works. It's got to be elegant, efficient, like the perfect mic drop moment, but for code.
So more than just knowing the syntax, it's like problem solving on steroids.
Absolutely. And that's where traditional AI has always kind of struggled. These competitions, they need strategic thinking, that adaptability, the ha-ha moment that's been hard to replicate in machines. Until now. Maybe.
Okay, cue the dramatic music. That's where these large reasoning models come in, right? LRMs, OpenAI's, O1OI or IOI, and O3. What makes them different? What makes these guys stand out from the usual AI suspects?
It's all in how they're trained. Think trial by fire, constant testing, learning from their mistakes, and evolving their strategies. The real game changer, though, their chain of thought reasoning.
Chain of thought. So they're breaking down the problem step by step, almost like how we would on a whiteboard.
You got it. It's not just speeding out lines of code. They're generating a whole thought process, a logical roadmap to a solution. That's huge for AI problem solving.
All right, time for the real test. They threw these models into the Codeforces arena. I hear it's like the Colosseum of competitive programming. How'd they do against the human gladiators?
Well, let's just say the results turn some heads.
Okay, spill it.
The standard language models, let's just say they were out of their league. But O1, this thing scored in the 89th percentile, meaning it beat almost 9 out of 10 human competitors.
Hold up, 89th percentile. That's not just per. All right, so get this. We're diving deep into a world where AI is going head to head with the best in competitive programming.
Oh, hey, our listener wants to join in. What's up?
Hey, can we wrap up the conclusion and the main takeaway?
Absolutely. It sounds like you're ready for the big picture.
Yeah, no problem at all. We can definitely jump to a conclusion and main takeaways.
So we've been unpacking some pretty intense stuff about AI crushing it in coding competitions.
And it really highlights the rapid progress we're seeing in the field of artificial intelligence.
So let's start with the key takeaways, then we'll wrap it up with a final thought.
Sounds perfect. So, what's the main thing we should remember from this deep dive?
Well, first, these large reasoning models are not just code generators anymore.
Right. They're actually developing reasoning skills, strategizing, and even learning from their mistakes.
They're not just spitting out code. It's like they're learning to think.
And that chain of thought reasoning is a real game changer. That's the key to their impressive performance.
It's like they're breaking down problems step by step like a human would on a whiteboard.
Exactly. And this isn't something that's been programmed into them. They are actually learning these strategies themselves.
Which is wild. Like they are actually figuring out how to figure things out.
And then you saw how O3 outperformed even the most skilled human programmers.
Yeah, it hit that crazy 99.8th percentile on Codeforces. That's like AI grandmaster level.
It's practically rubbing shoulders with the elite human coders. A huge leap for AI.
And then it took home the gold in the retrospective IOI challenge. The AI is calling its own shots now.
Yes, it was all about strategy and adaptability, not just raw computing power.
This shows that AI can truly learn to think critically and solve problems without human intervention.
But even with all the impressive results, it's still not about AI replacing human programmers.
No, it's really about a partnership. Humans and AI working together, right?
Precisely. It's about combining human ingenuity with AI efficiency, like a superpowered sidekick.
AI handles the tedious stuff while humans can focus on the creative, big picture stuff.
Absolutely. It's like when the calculator was invented. It didn't replace mathematicians, it helped them achieve more.
I like that. Not man versus machine. It's man with machine.
But of course, this technology comes with a set of ethical questions that we all need to be aware of.
Right. Bias, transparency, and accountability. Those are things that have to be front and center.
We're in uncharted territory, and we have to develop and use these models responsibly.
So that brings us to our final thought. AI is changing fast.
Very fast. And it's going to be a wild ride as we explore what's possible.
I think it's pretty clear that AI is going to continue to transform how we approach problem solving.
And we'll continue to be here on the deep dive to break it all down for you.
So until next, back to our listener. What's up?
So what about the thinking time? A long thinking time, or
Oh, yeah, that's a great question. Okay, let's unpack this thinking time thing.
Right. So the paper actually goes into some detail about how they measure that for the AI.
So they're looking at how long it takes the AI, O3, to generate and evaluate its solutions during competition.
What's fascinating here is they mention that O3 can think in parallel and try all the problems at once.
Which gives it this innate advantage over human competitors who have to approach the problems one at a time, right?
Exactly. But to make things fair, they estimated the model's score based on the median time of humans who solved that problem with the same failed attempts.
So they kind of leveled the playing field to compare AI and human performance.
But here's where it gets really interesting. They also considered how fast O3 could actually be if it was running on a very large cluster of GPUs.
Yeah, the model's true submission time depends on the number of available GPUs because it's all happening in parallel.
If they really maxed out the parallelism, O3 would have much higher scores.
It's like it's being artificially held back to give us a more apples-to-apples comparison with humans.
That's right, because it's not just about solving the problem, it's also about speed in competitive programming.
So the thinking time is not just about how long it takes the AI to process, it's also about leveling the playing field.
It's a crucial factor when we're assessing how this technology stacks up against human programmers in competition.
Okay, so that's a deep dive into the thinking time. Now, where were we?
I believe we were about to sign off for the day.
You're totally right. Okay, so until next time, keep those brains engaged and stay curious.
This is the Deep Dive signing off. Thanks for joining us today. That's a really interesting way to put it. When you say lunging, are you thinking about how these AI models approach a problem like they're pouncing on us? Oh yeah, let's hear it.
so can we do the reflection of this podcast?
Absolutely, I love that request. Let's really dive into what we've covered today and reflect on it.
Yeah, it's crucial to not just absorb information, but also to really think about what it means.
Okay, so let's start with this idea of lunging that you brought up.
When we were talking about the AI's thinking process, the word really seemed to fit.
You were picking up on how the AI seems to jump from one idea to the next.
And, it's not just a slow, methodical process. It's a dynamic and almost aggressive way to explore a problem.
So you notice the AI isn't taking one calculated step, but rather a series of leaps forward.
And that lunging, as we're calling it, is really a form of exploration. It's navigating the problem space.
That's the key. It's not a bug. It's a feature of how the AI is so effective.
It's that rapid series of thoughts that allows it to quickly refine its approach to a problem.
And that's all enabled by this chain of thought prompting that they use to unlock the reasoning ability of the AI.
Right. It's making the connections, jumping between ideas, and developing new insights along the way.
So thinking about the lunging and all that, let's zoom out again and look at the big picture.
Okay, so we've seen how these AI systems are learning to think, and how that thinking is a series of strategic lunges towards a solution.
And we talked about how it's not just about finding the answer, but getting there efficiently and adaptively.
All of this reinforces that these models are not just following static rules, they're actively improvising solutions.
It's wild to think that they're creating their own approaches and not just repeating things they've been trained on.
And I think it really opens up new avenues for problem solving. It makes you wonder how we can use this AI in the future.
But it also reminds us we have to be responsible when we use the technology and keep ethical concerns in mind.
Definitely. So we've explored the lunging idea and the big takeaways, which brings us to our final thought.
Which is that AI is changing really, really fast, and it's going to continue to.
And it's a wild ride, that's for sure, as we all try to figure out what's possible.
It's clear that AI is changing how we approach problem solving and how we will approach it going forward.
And we will be here to explore those changes for you in future episodes.
So until next time, keep those brains engaged and stay curious.
This is the Deep Dive signing off. Thanks for joining us today.